When it comes to the act of factoring quadratics, we actually have a couple of techniques. Now, the first method that most students learn is called the diamond method. Uh, let's look at how to use this diamond method with our quadratic from part 1, x squared plus 3x plus 2. So for the diamond method, it might be useful for us to first of all look at what do quadratics look like in standard form. Standard form is where the quadratic is written in this form ax squared plus bx plus c. So you just have all the x squared, the x term, and the numbers all just on right next to each other in order. So in standard form, we would use the diamond method, and what we would do is this: we would draw a big cross for our diamond method, and we want to take the a value and the c value. So we want to take the number that's multiplying x squared and the number that is adding on the end, and multiply them up on top of our cross. So in my example with x squared plus 3x plus 2, my a value, the coefficient of my x squared term, is 1. There's nothing in front of it, so that coefficient is 1. And my constant c is 2. 2 times 1 is 2. Then I take the middle constant, right, the constant on the x term, b, and put it on bottom. Here in this example, my middle constant is, or my middle coefficient, I mean, is 3. I have 3x, so my coefficient is 3. Then what I do in the diamond method is I need to rack my brain and come up with two numbers to put on the left and right, which multiply to this AC value and add to this B value, right? So what are two numbers that multiply to make the number 2? 2 and 1. 2 plus 1 is equal to 3. So these work, right? So I know that it'd be 2 and 1 because 2 times 1 is 2, and 2 plus 1 is 3. They're supposed to multiply to the top and add to the bottom. All right, excellent. So then what do I do with this? What do I do with this diamond that I just created? Well, let's say in my general example, my numbers were the Greek letters alpha and beta, right? Let's say I got alpha and beta. That would imply that this quadratic in general form could be factored to be x plus alpha. So x plus the left one times x plus the right number, beta. So that's how the diamond method works for factoring. So let's look at it in our example, right? So x squared plus 3x plus 2 should be able to be factored into x plus this number here, 2, times x plus this number on the right, 1. And if I want, I can quickly do a little FOIL to double check that that's true. X times x is x squared. Oops. X times 1 is x. 2 times x is 2x. 2 times 1 is 2. X plus 2x would make 3x, so I get x squared plus 3x plus 2. Cool. So it looks like my factoring worked. That is the diamond method. Now, when we're dealing with a quadratic where the a value is not 1, like in this one here where we have a 2x squared, the diamond method starts to fall apart. For example, let me do the diamond method real quick to this quadratic. I would have 2 times negative 3 is negative 6, 5 on the bottom. What multiplies to negative 6 and adds to 5? It'd be 6 and negative 1. By the diamond method alone, that means that this quadratic here is equal to x plus 6 times x minus 1, right? Plus 6 minus 1. The problem with that is that if I FOIL this and multiply it out, check it out. X times x would be x squared. Already, these are not equivalent, are they? Right? So because this one's 2x squared, this one's just a single x squared. So this is actually not true. This is where you have to, if you ever have an a value that does not equal 1, you need to go a little bit further than the diamond method, okay? So this is not correct. So to address this issue with the diamond method, we're going to add on a second step, another level to it that we're going to call factor by grouping. So the way factor by grouping is going to work is an interesting application of factoring techniques and the diamond method. Actually, it continues to use the diamond method, okay? But we're going to use it a little bit differently. So check this out. What I'm going to do is I'm going to take my original expression, 2x squared plus 5x minus 3. And what I want to do is I want to break up my x term into two x terms. I want to break it up into two x terms. So I want to keep 2x squared, and I want to keep minus 3, but I want to break up the 5x. What I'm going to do that is I'm actually going to use the two numbers I got from my diamond method. So I still want to use the diamond when I do factor by grouping. So I'm going to use this 6, and I'm going to write plus 6x. I'm going to use the minus 1 and write minus 1x. And check it out. This is the same expression still. I have 2x squared plus 6x minus 3. 6x minus x is 5x. Okay. So this is where the grouping part of factor by grouping comes in. Check it out. What I'm going to do is I'm going to group the first two terms and the last two terms. And what I want to do with these groupings is I want to think about how can I factor within that group? What can I pull out of 2x squared plus 6x that they have in common? 2x squared plus 6x both share a 2 factor as well as an x factor. So I'm going to pull 2x out of it. So what that means is I'm factoring 2x out of these two terms. What would I be left with? Well, 2x times x would make 2x squared, right? And 2x times 3 would make 6x. So do you see how this expression here, 2x times x plus 3, is the same as 2x squared plus 6x? They're the same, right? I'm going to do the same thing over here. What do these guys have in common? They both got a negative. So I'm going to write negative on the outside, -1 if you want to be pedantic. And what is my result when I factor a negative out of minus x minus 3? I get x plus 3. Oh, look at that. They're the same. What's crazy with factor by grouping is that if you do it correctly, this will always happen, actually. You'll always get this common x plus 3 or whatever it is that you get, right? This is where I need y'all to take a leap of faith with me and just trust what I say, and then I'll show you how it works in a sec. From this expression, I can factor x plus 3 out, right? If you think about it, 2x times x plus 3 is all one term. That's all one thing. And then the minus x plus 3, that's also all one thing. What do these two things have in common? They both have x plus 3. So let me pull that out. I'm going to pull out x plus 3. And what would I be left with? Well, from this guy, if I pull out x plus 3, I'd be left with 2x. From this guy, if I pull out x plus 3, I'd be left with minus 1. And look at that. I have factored it into 2x minus 1 times x plus 3. Let's double check through FOIL to make sure that these are actually equivalent, right? So what I'm going to do is I'm going to, over here, I'm going to draw 2x minus 1 times x plus 3. And let's FOIL these guys out. Now, I actually want to show you guys FOIL done slowly. So let's think about it slowly. So when I do FOIL, what's going to happen is this. 2x is going to multiply x plus 3. It's going to multiply the entire thing. So it multiplies x and 3. So I end up with 2x times x plus 3, right? And then the minus 1 multiplies both of them as well, doesn't it? So I end up with minus 1 times x plus 3. Then you distribute the 2x to the x and the 3. This is really what FOIL is doing when we do FOIL, right? This is what's happening when we do FOIL. So 2x times x is 2x squared. 2x times 3 is 6x. A negative times x is minus x. And then a negative times 3 is minus 3. Okay, so let's add these together. We get 2x squared plus 5x minus 3. And they are equivalent. So I factored correctly. Now I want to point out something to y'all. Check out the steps of these two series. They're actually the exact same, only in reverse. See, I have 2x minus 1 times x plus 3, 2x minus 1 times x plus 3. 2x times x plus 3 minus x plus x minus times x plus 3. 2x times x plus 3 minus times x plus 3. Distributing that, I get 2x plus 6x minus 3. Same thing here. And it combines to make the same original quadratic I had. Factor by grouping is actually just the FOIL method backwards. Okay? I personally really like factor by grouping. I know some of y'all may have learned the box method, and you are totally welcome to still use the box method. The box method is actually doing the exact same as what I just now did here. So I want to do one more factoring with a quadratic, just to kind of pull everything together. So remember, guys, whenever we are trying to factor quadratic, we actually can just start off with using our diamond technique, our diamond method. So what I'm going to do is on top I have a times c. So 4 times negative 7 is negative 28. And then on the bottom I have 3, my b value, right? And so I need to think of two numbers which will multiply to negative 28 and add to 3. Okay, factors of 28 would be 7 and 4, for example. I know that 7 times 4 makes 28. So if I do 7 and 4, that would multiply to 28. In order to multiply to negative 28, I need one of these to be negative. I'm going to make it negative 4 because 7 minus 4 is 3. This is really actually quite a challenging quadratic to be factoring, but once you're done with the diamond, all the hard part is done. This is actually really all the complex thinking, because the factor by grouping is, while it is maybe a bit intimidating when you first see it, it comes to be quite quick and simple, okay? So check it out. We rewrite the expression with the x terms split up by our two numbers we got from the diamond method. So we have 4x squared plus 7x minus 4x minus 7. I group up the first two and the last two terms, and I try to factor them. What does 4x squared and 7x have in common? They both have an x. So I pull x out, and I'm left with 4x plus 7. What does minus 4x and minus 7 have in common? They both have a negative. So I pull out negative, and I'm left with 4x plus 7. What do you know? The binomial within the parentheses is the same. So I can factor it out, right? I can factor that out of the expression, and I'm left with, I have 4x plus 7 on the outside. And what am I left with? I'm left with x and minus 1. And I've factored it, actually. This is the factored form. I could use FOIL to multiply this binomial out, and they should equal the same thing. I just want to make sure that people realize and remember the whole reason why I'm doing factor by grouping, as opposed to just the diamond method, is because my a value here, right, the coefficient in front of x squared, is not 1. If I have a quadratic where the coefficient on x squared is 1, I could just do the diamond method and stop there, like we did in this problem right here, right? I just did the diamond method and I was done. But if you ever have a coefficient in front of x squared, like I do here in 2x squared, oops, or like I do over here in my factor by grouping second example with the 4x squared, I gotta do the extra step, okay? Now the final thing I want to show y'all in terms of factoring is something that I call the double cheek method. Now this is how I personally factor, and your skill with it kind of comes with experience, but I think it's a really useful way to be able to factor over time, of course, because as we progress in our math and we complete more challenging problems or more complex ideas, factoring becomes more of a step, kind of like multiplication has become for you guys in algebra, right? In elementary school, multiplication used to be the actual problem. You were asked to multiply two numbers. Now in algebra, multiplying is just expected. Similarly, as you go on in math, factoring becomes more of a expectation that you can do it, not as much a actual problem. So the double cheek method works like this. I just draw my double cheeks, right? I draw my two parentheses. And what I'm doing is I just know that when I have this factored, this is the structure that my factored form should look like, right? And I rack my brain and I think about what the terms would be in the final factored form. I know I got to have two x terms, right? That's how it always be. And so what would those x terms be? Well, I need to think about it, right? What would multiply to make x squared? X and x. So right away I know half of what my factored form is going to be. So now let's think about the 2, because I know that typically what happens when I'm in factored form is that I would have some numbers adding or subtracting over here, right? What's going to multiply to 2? Well, 2 and 1, wouldn't it? Now, all I need to do is put a plus or minus in between these guys, right? So what I need to do is think about what would I need in order to make the 2 and 1 multiply to positive 2 and add to 3x. Well, if I make these both plus, see how positive 2 times positive 1 would make 2. 2x plus 1x would make 3x. And through just a little bit of logical reasoning, I have been able to factor this right away. Now let's see how, that was a bit of an easy quadratic to factor. So maybe let's see one that was a little bit more challenging for us, like the 2x squared plus 5x minus 3. In this problem, I'm going to once again do my double cheek. Double cheek, double cheek. And I need to think about what would be the two x terms that will multiply to make 2x squared. I think it would be 2x and x, because 2x times x makes 2x squared. What would be two numbers that could multiply to negative 3? Well, 1 and 3 could multiply to negative 3. And finally, I just need to think about what would I need my pluses and minuses to be. This is where you start kind of considering the options in your brain, right? If I need to multiply to negative 3, I need either this to be plus and this to be minus, or reversed. I need this to be minus and this to be plus, don't I, right? Because positive 1 times negative 3 makes negative 3, or negative 1 times positive 3 would make negative 3. So these are my two options. Either it's plus and minus here, or it's minus and plus here. Well, let's think about what our middle term is then. In order to get 5x, I would need, in order to get positive 5x, I would need to have the plus here and the minus here. And the reasoning being that if I look at my x terms, I would get minus 1 times x is minus x. 3 times 2x is 6x. 6x minus 1x is 5x. And so I have factored it. Now I know the double cheek method is a bit odd. It's a lot of kind of mental math, but it is something where I would say maybe try doing this idea when you see problems where it's a simple quadratic to factor, and work on getting that experience in using it, because eventually you will be able to do factoring problems like this super quickly and super simply. If the double cheek is not working for you, or you're having trouble with it, remember, we always have our diamond and our diamond method and our factor by grouping, right? The diamond method combined with the factor by grouping will always work. I just like to show y'all the double cheek method because I trust that you guys can, through practice, learn to use it. And I think that learning to use this method of factoring instead of using the tricks of the diamond and the factor by grouping can eventually help you out in the long run in math because it's quicker and it is less steps.